Guys, welcome to HVAC Startup Technicians. So today we want to talk about voltage on air handler. We want to talk a little bit about heat kits, how to do the BTUs, but we're not talking about design. We're talking about when the system is running, how we calculate our CFM, how we know on a air handler what is happening. So I'll go through some numbers. I'll take the time to jot some numbers down, some notes down as we go ahead. I don't normally do notes, but this video is very important, and I think it's very important that we go through this. This is one of the things that you don't find a lot of videos on, and I want to go through this with you so you could understand and make yourself more valuable in your workplace to know how to work these numbers out. So the first thing we want to know when we're talking about heat kit and voltage and amps is your voltage up, your amps going to be down. And I'm going to explain this. So if you had, let's say you're working at 10,000 BTUs, and you had 240 volts going to that heat kit, and you have 208 volts going to that same heat kit, you will get a difference in amperage. So I'm going to explain to you. You have 15,000 BTUs and you have 240 volts coming through there. Your amps is going to be 62.5. So it's really important to know that. Also, if you have 208 going into 50,000 BTUs on that heat kit, you're going to have 71 amps. The importance of that is to know that if you have that coming in and you know what your voltage is, when you do a test on that amp and your amp draws on that electric heater, you know exactly what it is doing. So it's just a brief introduction. Let's go further and dive in deeper. I hope I'm not losing anyone, but we're going to talk about BTUs now on an air handler. How do we know on an air handler how to do our BTUs, how to figure out what our BTUs are on an air handler? There is a formula for that, and I'm going to give it to you. You want your CFM times your delta T, and as you know, your delta T is the difference between your return and your supply, times 1.08. And that will equal your BTUs. So your CFM times delta T times 1.08 will give you your BTU. Very, very important stuff if you want to know what that system is doing, how do you calculate that system and know if it's working correctly, if it's working efficiently. These are the numbers. We're going to dive down into this deeper because I just talked about CFM. That was the first formula I gave you. I said CFM times delta T times 1.08. But I did not tell you how to work out your CFM on an air handler. We also have a formula for this also. So the formula to work it out is your volts. We talk about volts. I gave you an introduction to volts when I started a couple minutes ago. Times amps. We talk about amps, and I told you that if your voltage is up, your amps going to be down. So let me recap. Volts times amps times 3.41. Whatever number that you got there, we're going to work that out in a minute. And then the second part, so it's a two-part math to get your CFM, is your delta T times 1.08. And what we're going to do, once we get that number, we're going to divide. All right, guys? So let me just give you an example. We're talking about, again, CFM, how to calculate your CFM on an air handler. And we're mainly talking about our heat kit, our electric heat, whatever number you prefer or whatever name you prefer, that's it. So let me dive into some numbers. If we had 240 volts coming in there, And let me say we had 62 amps. What we would do, and I've worked out some of the numbers, we go take 240. Our amps was 62. We go times that by 62 times 3.41. And I already worked the math out. It was giving us something like 50,740. Now that is the one part of the math. So what we're going to do again in that air handler, we're going to take our temperature probe and we're going to put one in the return and one in the supply. That will give us our delta T. So what we're going to do now is we're going to take, so let me say our delta T was 45. We're going to take 45 times 1.08. That would give us 48.6. And I'm just showing some numbers out to show you. So we're going to take that 48.6 and divide it by the first number, 50,740. And that will give us a CFM of 1044. Really, really important stuff, guys. And this part of this video is one of the most important thing. I have gone through videos and tell you how to work out CFM on a heat kit. It's 90 CFMs times whatever you have coming through there. So I'm not going to talk a lot about that. I think I have another video telling you how to work out delta T and how to work out, not delta T, sorry, how to work out BTUs on a heat kit. So again, it's worth repeating because I think that what I just went through, I may have gone through it a little bit fast, and I want you guys to grasp it. And I'm gonna go repeat what I just said about your CFM, how to work out your CFM, because I know the math could be a little bit complicated. So we're gonna do volts times amps times 3.41. Yeah, the 3.41 is a number that is always there. So that's just a formula. There's no way of changing that. So that's one part. And then we're going to take our delta T times 1.08. Whatever we get. So as I said, I did some math and I did 240. If that was our volts, times 62, that was our amps, times 3.41, and we will get 50,740. What we're going to do when we take our temperature probe, we're going to get our delta T, which is going to be the difference between our supply and our return. We're going to take that 45 times 1.08. That is going to give us 48.6. We're going to take the 48.6 and divide it by 50,740. That is going to give us a CFM of 1044. So on that, by standard numbers, we're just getting a little bit above 1,000 CFM on our heat kit. And it will be very important to kind of match what your heat kit and your outdoor is doing, which I will dive deeper into another video. Now, if this video you found it educational, I would be happy if you would like and consider subscribing. All right, guys, thank you for taking the time to look at this video, and please don't leave without subscribing. See you guys. Bye.